today I'll be talking about this question. So this was a contest hosted by NSUT called CP Recruitment and for recruitment of some club. And so I found this exact question to be really interesting. At least for me, this was interesting. And to talk about other problems, like question one was very easy and just basic implementation one. Question two was very tricky and fun and unexpected. That deserves a different video, I think. Like it's a one-line solution, but like it was really funny. And this was the third question, and the fourth question was just basic pre-computation based, like prefix arrays and just generation of some terms. So that was also basic, at least for me. Like no new concept was involved, but this was something I had to think through. Okay, so let's read the question. Okay, so the question states that you have to find the length of the subarray that gives us the maximum mix. So I really like that the problem statements are really small and clear and crisp. So maybe Akshit Dumondial created these problems, so shout out to him for that. And moving on to the problem. So if you don't know what a MEX is, so MEX is basically this is a very popular term in competitive programming. Credits to Harisam Sharma who told me this. And so basically it means I haven't solved any question on MEX till now, just I have heard this term. So mix of a few numbers is, let's say, a list of numbers or a set of numbers is the minimal non-negative integer that is not in that set. So let's say if we start from 0 and 0, 1, 2, 3, whichever number is not present will be the mix of that set or number. So in this case it will be 0, and in this case 0, 1 and 2 are present, so 3 will be the only non-present number in this set, and it is basically the minimal non-negative integer that is not present in the set, right? Pretty straightforward. And you just have to print the smallest length subarray that has the maximum mix. Okay, so let's jump straight to the solution then. Okay, the constraints are 1000, which was weird. I thought it would require like of n square complexity. I don't know how much time though. There is no time in this website for some reason. Okay, so we are given an array. I've just inputted an array right here, and there are no test cases weirdly on HackerRank. Okay, and then the array holds a number of 10 to the power 6, so it can be held in an int. Okay, so let's discuss the first test case. So what it means is basically 12045, and you can see that the mix of this is 3, and the minimum length subarray is 120, which holds every condition of like the maximum mix and also being the smallest length. So the thing to note is that this is a subarray and not a substring. Subsequence. It's not a subsequence. So what this means is if there's 1, 2, 1, 2, and if the 0 would have not come here, and let's say 4 would have been here, and there would have been 5 here, then the smallest subarray that contains the maximum mix to be 3 is basically the maximum mix is 3. So the minimum length subarray that has the mix equals to 3 would be this, and the length would be 4, and we would output 4 here, right? Because we need 0 to have a mix of 3. So at first I did not know what to do, and but later I found out a really cool way, and I'm just going to code it right in front of you. Okay, let me explain what I've coded till now. So I've created this maxi. So my first observation, or the first thing to calculate, was maximum MEX. So what will be the maximum MEX? So we can see that maximum MEX is the MEX of the whole array. This is pretty straightforward thing to note down, because the more numbers we have, the MEX cannot decrease, right? It can only increase. So the more numbers we have, the greater the MEX becomes, right? Or it does not changes. It just does not go downhill, right? So it does not decrease with increasing in numbers. So what I did was calculate the MEX of whole array. So to do that, what I took was a Boolean vector, and I stored n plus 1 integers. And you might ask, why n plus 1 integers? And so this is basically storing that if a number exists in the array or not. Okay, let me explain why n plus 1. Why n plus 1? So if we see, let's say the n is the length of the array, and so what can be the maximum MEX of an array of length n? Yes, you guessed it correct, and it is n, because for the best case scenario, your array should look like this: 0, 1 and 2. Let's say n is equals to 3, so your array will look something like this, right? And this can produce a maximum MEX of 3. You can just clearly see, right? Any other configuration, like let's say if you do this, this will only decrease the MEX, right, to 2 basically. So I just declared a vector of bool and gave it n plus 1 length. So for every number there is a false statement, meaning that it is not present at the in the array, right? So actually this might not be useful. No, this is useful, right? This is useful. Yeah. So I'll explain why n plus 1, right? Because to calculate the MEX, I'm using this bool array. So what I do here is, if the array element is less than or equal to n, that means it is inside the range of this and also this 3. Okay, so it should be in this range 0, 1, 2, 3, because these are the candidates for MEX, right? So what do we do is, basically we turn them to true because they are present in the array. So MEX is not present in the array, so I just turn them to true. Let's say if 2 is present, then it turns out true, and like so I do that for every element. And after doing that, the first false element from the start will be our MEX, right? So this is the approach. I hope you understood it. To find the MEX of the whole array, so what we do is, 2 is false, we just leave this, then 1 is false, and we just go from the start. Whichever element does not have a false, we just take that to be the MEX. That is the MEX, right? And in the max case scenario, everything like 0, 1, 2 can be present in the array, and then the answer would be 3, and that is why the n plus 1. Okay, I think that is clear. And now what I do is, basically I explain the thing that I did in code, that is declare this is the MEX, this is the MEX, and so this is -1 at the start. You can actually just ignore this also. And if max of I is false, so the first false integer is the MEX. Okay, so now we have the MEX. How will we find the subarray? How will we find the subarray of least length having that MEX? How will we do that? Okay, so here is the fun part. So what is a subarray exactly? So subarray is an array made after deleting one or more elements from the starting and ending of the array. So please understand this really clearly, that it is actually just the same array and some bits of it deleted from the start and the end, and not from any random location, right? So this is really important, and this will shape our answer, which I will code right now. So we have the mix, right? What do we do after having a mix? What we do is basically we actually create two loops, and we go from I equals to 0 to I less than n, and we check if a of I, first of all, the answer is going to be stored in len, let's say length, right? So this can be n at the start, so it is full length, so this array is full length. And what we can do is, if a of I is greater than or equal to, we can just make it greater than, because equal to means that is a present in the array and the mix is never present in the array, so we can just declare it to be greater than. And what we can do is, if a of I is greater than the mix, then we can just remove it from our array because it is not required. Why it is not required? Because let's say we incur 5, we can remove 5 and it won't affect the mix, right? In this scenario, right? Even 4 is not needed. So what we're gonna do is, if a of I is greater than x, answer, and since we only require the length, we can just length minus minus instead of removing it from the array. And when do we stop? We stop when we find a number that needs to be included. So anything that is left to it or right to it, like that number needs to be included, right? So if we are going from the start, then any number that needs to be included, then the right part of it should also be included. So I will actually break here and I'll remove no more elements than this from the start. And now we'll do the same thing from the back end of the array. I think there should be an efficient way to do this in C++20, but I'm just going to do it the OG way, right? And I'm just gonna decrease, and similarly, yeah. And I thought this would give me the answer, and this is actually giving me the answers 4 out of 5 times. So there is an edge case that needed to be solved. I actually took a lot of time in figuring this out. So what that edge case is, please pause the video and try to guess what is the edge case that I'm missing. So after all of this, we just gonna print the length, and this will have the length of the array that is required, minimal required, and have the max of the whole array, that is 3, and that is the maximum max, right? So the only edge case this has is, we can actually remove this. So the only edge case that this holds is that what if the max is 0, right? If max is 0, then what will actually go on is, if a of I is greater than answer, then every element of that array would be greater, and the length of the subarray would come out to be 0, because there is no element that is smaller than 0 and is helping to create a max of 0. So in that case, what we have to do is just state that if length is equals 0, we can just display 1 because we can just include one random element and this would cause the MEX to be 0, and we can actually say else we can just say cout length, right? Yeah, so this was the solution and this will pass. I'm not gonna submit this because it is logged. I don't know if I can submit this. Yeah, but this is the solution and it works. I can say that for sure. Okay, I don't think I can submit. Maybe I can. I don't know. Okay, but you get the gist. So if you're watching till now, so I urge you to like this video and comment on it and share it, or just subscribe if you loved it, right? Let's see if this works. Compilation error. Okay, we should have run it here first. Okay, so this is not the test case. Length was not declared. Okay. Okay, let's just take it length. Copy the test case. Let's run this first. Okay, so this was the test case. Length int overloaded. Okay, we forgot a less than. Just give me 3. Yeah. So yeah, just for the sake of this video, just this has gone really long, 17 minutes of video. Oh no, it failed for test case 1. Huh. Oh, why does it fail for test case 1? Oh no. This test case 1 should pass. Weird. Let's say else if length is equals n minus 1, let's say n, then we can see out n, right? Because if the MEX is n, let's say this might work. I don't know why, but this might work. So if the MEX is 0, then just display, and if MEX is n, then we can actually display n, right? We will need all of the numbers. That looks good to me. That is weird. Okay, so the test case 1 passes. But why does that happen? Let's make a MEX of 0. So this is 1, 2, and 3. Now let's see if length is 0. So we should probably get an answer of 1. Minus 5. Okay. So this is an error. Why is it? Oh, okay, I get it. Okay. Since this loop is running basically 2 times, so 2 times n, and what this does is basically I've taken the length to be n at first, and after decreasing it for every number like once, uh, traversing it in the forward direction, so it never really stops, right? We assume that it stops somewhere, so that is the reason that it works in all the other cases. And if you don't have any number that is less than or equal to the MEX, so in that case it does not stop, so it traverses the whole n, and then it traverses the whole n again. So first it actually goes to 0 and then it goes to -i. Yeah, so that was the issue, and I have fixed it now. Yeah, so that was the solution, and I don't think you are watching till now, but if you are, I love you. Thank you for watching. Subscribe and turn the notification bell on, maybe.